Okay, so this video is to help people who are struggling with working out relative formula mass or don't understand what a relative atomic mass is. If you haven't watched the video yet on decoding chemical formula and you're not really comfortable with using symbols like C2H5 and not knowing quite how many of which things there are, you need to go back and watch the chemical formula video first, otherwise this is going to be very difficult. Okay, so here are three sets of symbols taken straight from the periodic table. You get these in every GCSE exam. You do not need to learn the values. Okay, so when you have a periodic table symbol, you have first of all the symbol for the element, then you have two numbers. The biggest mistake I see being made here is people using the wrong one. Now the top number is the mass number. There is absolutely no excuse for getting this wrong in a GCSE exam, because on the periodic table you're given there is a key which tells you that the top number is the mass number. So if you start doing this using the bottom number, you are going to be generally about 50% out. Okay, so what do these top numbers actually mean? Well, all atoms' masses are measured relative to a carbon-12 atom. That is the standard atom that we use for this scale. So it's a relative scale, it's not 12 anythings, it's relative to carbon-12. So in our wisdom, chemists have decided that carbon weighs 12, so we give it a mass value of 12. If we look at hydrogen, it has a mass value of 1. That means that one hydrogen atom weighs 1/12 that of a carbon, which is what it does. Oxygen, on the other hand, is slightly heavier. It weighs 16 compared to 12, so effectively it's 16/12 of a carbon atom. Now you will have heard about protons and neutrons, and obviously this is tied in here too. The reason we've set the carbon to be 12 is that in the nucleus of a carbon atom there are exactly 12 particles, each with a mass of 1, giving a total of 12. So although it seems a bit of an arbitrary decision to make carbon 12, it does actually make sense when you get down to this subatomic structure. Okay, so this top number is normally referred to as AR, the relative atomic mass. That is literally what it says. It's the mass of one atom compared to something else, in this case carbon-12. Now, you'll never be asked to work out one of those because you've obviously got the periodic table with all of them on it. Okay, so what you're going to get asked in the GCSE paper is not relative atomic mass, but relative formula mass. The symbol is MR. M for mass, R for relative, and the formula has just disappeared somewhere. So, first example, the simplest one we can come up with, two hydrogen atoms stuck together. 2H, 2 times H. So you've got 2 times 1, the 1 is the mass of the hydrogen, which gives us our answer 2. Now this is often a 2-mark question in a GCSE paper, but it tends not to be quite as simple as this one. So here's a slightly harder one, water. H2O. Now, if you've watched the earlier video, you'll know that that 2 is talking about the H, not the O. So we have 2 hydrogens and 1 oxygen. That gives us 2 times 1 for the hydrogen and 1 times 16 for the oxygen. Add them together, you get 18. It's important that you do the multiplication first. If you don't, you'll do 2 times 1, which is 2, plus 1, which is 3, and then 3 times 16, which isn't the answer. You must get the order of multiplication and addition right. Next step up, we've now got two numbers, so we've got C2H4. Following the same logic, this is 2 carbons and 4 hydrogens. So here they are. We substitute in the weight of carbon, which is the top number, 12, and 4 times 1, top number again, for the hydrogens. Add the two together, the answer is 28. Right, to make this as hard as we can, here's a chemical that I've pretty much just invented. It probably exists, but the whole point of this is simply to work out its mass anyway, so it'll do. Okay, we've now got brackets, which are going to make life slightly more complicated. So, first of all, decode the formula. We have 1 carbon, we have 2 hydrogens here, but then we have another one here, and there's 2 lots of it. So in total, we have 4 hydrogens. These 2, plus 2 more here. On top of that, we've also got 2 oxygens. Because the O is in the brackets, that 2 refers to both the O and the H. So when we write it out, we have 1 carbon, 4 hydrogens, 2 oxygens. When we put in the masses, that gives us 1 times 12 for the carbon, 4 times 1 for the hydrogens, and 2 times 16 for the oxygens. We do the maths, getting everything in the right sequence again, we should get the answer 48. That's about as hard as a relative formula mass question is ever likely to be at GCSE. Now, more and more, they're not relying on you looking up these numbers on the periodic table. They're actually often starting to tell you those in the question, which makes it even more straightforward. These should be 2 of the easiest marks on a higher tier chemistry paper. So make sure you can do this technique, because if you can't, the later techniques such as empirical formulas and reacting mass calculations are basically not going to be possible for you.